हेलो एवरीवन, इरिगेशन एंड वाटर रिसोर्स इंजीनियरिंग में आप सभी का स्वागत है। इस सब्जेक्ट में अभी तक हमने पाँचों यूनिट्स ऑलमोस्ट कवर कर ली हैं। टुडे इज़ द लास्ट लेक्चर ऑफ दिस KC 078 टॉपिक एंड द टॉपिक वी हैव टू कवर इज़ द मेथड्स ऑफ लिफ्टिंग द वाटर बाय द पंपिंग एंड ऑल्सो वी विल बी डिस्कसिंग अबाउट द इन्फिल्ट्रेशन गैलरी। सो लेट अस नाउ डिस्कस फर्स्ट ऑफ ऑल द एडवांटेजेस ऑफ वेल इरिगेशन ओवर द कैनाल इरिगेशन। हमने लास्ट क्लास में भी इसको डिस्कशन कर रखा था, that is the wells are under direct control of the owner, so it can be used as per the owner itself, that is it was in the field. Second point is that wells can be located such that they command any required land. So if you want the irrigation for a particular land, let's say L1, and the canal is at a very much larger distance, so due to the friction losses and other factors, the water cannot be brought from the canal. In that case, we can use simply the well that is present at that required land L1. Third is that the supply from the well can be maintained fairly constant, and that is not the case with the canal irrigation that you already have studied. Fourth point is that duty of the water in the well irrigation is generally higher. Fifth point is here that the well irrigation generally does not fail in the drought seasons, because the water will be stored in the water table there, that is underground. Then sixth point is that more than one crop can be grown in a year for this well irrigation, using this well irrigation. And the well water is what it is conducive as per the environment. If it is winter, then it will be warm, and if it is summer, then it will be cold. So well water is more suitable to the crops as compared to the canal water. अभी तक तो हमने बात करी एडवांटेजेस वेल इरिगेशन के, बट वेल इरिगेशन के डिसएडवांटेजेस भी हैं जिसकी वजह से वी प्रेफर फॉर द कैनाल इरिगेशन. So water has to be lifted, so working expenses are high in wells, so you have to go for the energy, okay, so you have to go for the power or the energy. And second point, you can see here that the pump defects and the disruption in electric supply lead to disruption in irrigation. So that is one major problem which is encountered in the village area. Well water is free from the silt, thus no manuring value to fields. So if there is no organic matter, if I talk about the canal supply, then what happens is there, the canal supply is containing the organic matter also along with the silt that it is carrying, okay. So water mein the silt is there and also the organic matter, some part of organic matter is there. So it also provides the manuring ability, this water is having the manuring ability. But यहाँ पे well water में क्या है, it is free from silt. Fourth point is that the strainer replacement is required at periodic intervals, and that is a very costly affair. So usually what the people do is that they go for a new well development. Fifth is that maintenance cost is very much high as compared to the canal, which is basically in the scope of the government. Now let us talk about the suitable site for the tube well. Tube wells should be selected at a site where the large underground water reservoir exists. So in that case what will happen, it will be easier to extract the water, and the groundwater level, if it is very much high, or I would say if there is a large water reservoir in the ground, then it will be very much beneficial for the environment also, okay. So that the replenishment is not required in that time. It is placed usually green and dark, the place wherein the tube well has to be located, it is usually green and dark. Why? Because of the moisture, it indicates a high water table. Second point is that how you can locate it, by certain worms and insects such as gnats, they hover around that spot. तो अगर यहाँ पे इस तरीके से आपको कोई भी लैंड दिखता है, so you can go for that site for selection of the tube well. And third point is that by actual boring you can go for the site for the tube well. Second point is that if the geological excavations indicate the ridges and depressions of impermeable strata, then tube wells should be located where there is the valley. यानी कि वैली का मतलब क्या हुआ, okay, it is something like this. If the surrounding area is what, impermeable and all, and there is one valley, so what will happen, the water which is there, it will be coming and getting stored in this region. So you will be getting a full supply of water. So the tube well will be located in this zone. Next point is that area should have well distributed and uniform demand for irrigation throughout the year. मतलब वहाँ पे यदि क्रॉप्स ही नहीं ग्रो करनी है हमको ऑल अराउंड द ईयर, सो वी शुड नॉट गो फॉर द ट्यूब वेल बेसिकली. इट शुड बी सेंट्रली लोकेटेड सच दैट transient losses are minimized, so that entire area is covered. Okay, if this is the area, okay, or I would say this one, so the well number 1 is there and well number 2 is there. तो इस तरीके से होना चाहिए कि all the direction should be covered in a easier way. अगर well number 2 में हम जाते हैं, this one here, so the transient losses will be higher, the transmission loss होंगे that will be higher. Now let us talk about the methods of lifting the water. So how can the water be lifted up from the ground level? So sorry, not from the ground level, but from the underground reservoir to the ground for our purposes, for our use. First is the indigenous method and the mechanical method. तो indigenous method जो पहले से use होते आ रहे हैं और उसमें पहला जो method है that is the basket method, और that is the basket, and also there is one method that is the bucket method. Okay, bucket method. तो bucket method में क्या है कि this a person is simply by using the rope and this lever arrangement is there, and it is the bucket is lowered up, and it is the most conventional form of this thing lifting the water. Second is the dune method, okay, wherein this dune is used and this fulcrum and the weight is used. So via this fulcrum the water is, this is the rope, it is pulled up and the water is lifted from this portion. Then is the Archimedean screw. Okay, in the Archimedean screw what happens is, this is the water level from where the water has to be extracted, and this has been placed at around 30° angle. So this is a type of screw जहाँ पे इसका जो lower level है, this is the lower level, this is under water. Now what happens is that when this handle is rotated, then the screw will move, and as the screw moves, then what will happen, it will take in the water and it will take it with it to the top, wherein the water will be stored in the this reservoir here, और यहाँ से फिर इसको fields में हम transfer कर सकते हैं. Then the fourth is the ढेकली और the lever method. अब इस lever method में क्या है, there is a vertical post, वही simple physics है आपकी, that a weight is there, okay, when you pull this down due to the weight it will be at this original position. जैसा कि आपने रेलवे के फाटकों में देखा होगा, इस तरीके का अरेंजमेंट आपको देखने को मिलता है. ओके, सो व्हेन दिस इज पुल्ड डाउन हियर, ओके, सो दिस इज इन दिस पोजीशन एंड देन द वाटर कैन बी लिफ्टेड फ्रॉम द बकेट. तो बकेट का इस्तेमाल करके दिस लिवर मेथड कैन बी यूज्ड फॉर ड्रॉइंग आउट द वाटर. एंड दिस मोटा और द चूरूस मेथड, जहाँ पे वी आर यूजिंग द लेदर बैग्स बेसिकली, तो these are the leather bags which are used, and bullocks are used for lifting up the water. Okay, so the water, this is the lever arrangement, this is the pulley arrangement basically which is there, and the water is recovered like this. So water is being lifted up. Okay, this is the entire portion, water is lifted up and then it is being transferred here. Another is the Persian wheel method. Persian wheel method is basically, it is the system wherein gear arrangement is there. Okay, what is the gear arrangement? This is a sort of gear arrangement जहाँ पे this is the movement of I would say the vertical axis is this one, जिसके about movement होता है, और this is the axis जहाँ पे the shaft is there and the shaft will be rotating in this direction, in this way. Okay, so this is also a portion wherein the shaft is being attached. So यहाँ से water की lifting होती है, and then यहाँ पे what is the thing is that there are multiple buckets that are filled at a time. तो इससे फ़ायदा क्या होता है कि it is used for the irrigation of a large field. अभी तक तो हम bucket method और अलग अलग methods को देख रहे थे जहाँ पे we are to use for our own purpose, but यहाँ पे क्या है, a large amount of water is being withdrawn and then it is used for the field irrigation. So these are few methods for the lifting of water, and there are some mechanical methods wherein windmill can be used, hydraulic ram can be used, and also the pumps can be used. So if we talk about the pumps, so the discharge from the shallow open well is usually less, so the pumps which are in use are the following one. तो shallow open well से जो pump use होते हैं वो बहुत ही कम cost के और they are very easily operated. So first is the hand operated pitcher pump, second is the windmill operated plunger pumps, third is the turbine pumps, gear pumps and centrifugal pumps. So these are used for very much less discharge. Next we talk about is from the deep well and the tube well, we can use the deep well turbine pump, deep well jet pump and the airlift pump. So turbine pump, jet pump basically use होते हैं और airlift pump can also be used. Okay. So you can see here deep well turbine pump, it is a sort of this type of figure wherein the diameters available are 10 to 35 centimeters. Second is the deep well jet pump. In this what happens, you have already seen it in your homes also, that in this for small discharges it can be used and it is available for diameters 10 to 20 centimeter. It lifts between 6 to 50 meters. So this is this you have already seen at your homes also, but you use it for the lifting up of the water. Now this one more point here, what is the factor for selection of the pump for tube well? आप कौन सा पंप यूज़ करेंगे, इसके लिए आपको देखने पड़ेंगे कुछ फैक्टर्स. फर्स्ट इज द डायमीटर एंड डेप्थ ऑफ द वेल, सो दैट विच टाइप ऑफ वेल, सेंट्रीफ्यूगल पंप आपको यूज़ करना है कि टर्बाइन पंप यूज़ करना है. सो यू हैव टू गो फॉर दीज इंपॉर्टेंट फैक्टर्स. जहाँ पे सेकंड पॉइंट इज द डेप्थ ऑफ द वाटर टेबल. थर्ड इज द ड्रॉ डाउन दैट इज बीइंग कॉज्ड बाय द लिफ्टिंग ऑफ द वाटर. फोर्थ इज द सीजनल वेरिएबिलिटी ऑफ द ग्राउंड वाटर टेबल. फिफ्थ इज द ड्यूरेशन ऑफ पंपिंग. सिक्स इज द कैपेसिटी एंड देन इनिशियल एंड मेंटेनेंस कॉस्ट एंड द पावर रिक्वायर्ड. तो इन्हीं के हिसाब से हमारी जो रिक्वायरमेंट है एंड ऑल्सो द वाटर विच इज़ टू बी विड्रॉन, बिकॉज ऑफ दोज टू फैक्टर्स वी विल बी गोइंग फॉर द सिलेक्शन ऑफ द पम्प. Now the last topic for today's class and also the subject is the infiltration galleries. So infiltration gallery क्या होता है, पहले हम उसको देखते हैं. It is something like this. तो इसमें there is a river or a stream or a channel wherein the water is present. Now we have to get the water from this region. Now this is the porous boundary or a permeable boundary. Okay, this is the permeable boundary here. Now what we do, we create a gallery here. अब गैलरी ऐसी, गैलरी कैसे, इट इज़ अ गैलरी, दैट मीन्स अगर आप इसका टॉप व्यू देखते हैं, सो इफ यू सी द टॉप व्यू इट विल बी समथिंग लाइक दिस. तो इस गैलरी में द वाटर इज बीइंग स्टोर्ड लाइक दिस. ओके, दिस इज द गैलरी वेयर इन द वाटर इज स्टोर्ड. दिस इज द टॉप व्यू ऑफ द गैलरी. तो ये कुछ 100 मीटर के लिए जा सकती है, 10 से लेकर 100 मीटर तक ये इसकी लेंथ होगी. और ये कहाँ पे रन कर रही होगी, इट विल बी रनिंग along the bank of the channel, okay, along the bank of the river. So that is there. अगर हम क्रॉस सेक्शन की बात करें तो this is the gallery wherein the water will be stored. Okay, with the help of the pipes here, the water will be stored in this gallery. और यहाँ पे इधर से इसे हमने gravel packing कर रखी है and also porous drain pipes are used. This is foundation that has been created and this is the gallery so that seepage does not take place. तो ये foundation है so that seepage will not be taking place and we can utilize this infiltration gallery which is also acting as a collection well. क्यों, क्योंकि यहाँ से जो भी water होगा that will be simply transferring it in the gallery. तो अगर हम अब points को देखें तो water flowing onto the land surface goes into the well by the way of an artificial tunnel and that artificial tunnel is known as the infiltration gallery and it extends into the aquifer. Second point is that they may be having width of about 1 meter, depth of about 2 meter and length varying from 10 to 100 meter. तो अगर आप टॉप व्यू में देखेंगे तो आपको ये समझ में आएगा, that is the length and width of about 1 meter. So the width here is, this is the 1 meter width. Also you can see here that the depth is what, around 2 meters. अगर हम इसका टॉप व्यू देखते हैं तो दिस इज द टॉप व्यू जहाँ पे आपको इसकी लेंथ पता चलेगी जो कि 10 से लेके 100 मीटर के अराउंड होती है. सो दीज आर द चैनल्स ऑफ वाटर बेसिकली विच आर रनिंग पैरेलल टू द बैंक. तो अगर सबसे सिंपल वर्ड में यही मैंने बोला आपको अभी कि दीज आर चैनल्स ऑफ वाटर दैट आर टेकिंग एंड स्टोरिंग द वाटर इन इट्स बैंक and are running parallel to the this thing, parallel to the bank of the river. Last point is this, that for the best yields gallery should be aligned parallel to the water table contour as to capture the maximum subsurface flow. So that is also there, so that the entire water is coming and it is draining on to the infiltration gallery. Now let us see here that if you see the cross section here and this is the infiltration gallery and infiltration gallery में जो water level है that is the small h. Okay, and also if you see that this is the water table here. This is the water table. When the discharge is taking place, okay, if the river flow is like this, okay, and the river water is draining into this infiltration gallery, ये वाला तो this face is nothing here, but this face is the porous face and it is receiving the water. It is receiving the water from this end. Now you have to assume here this strip of dx width, and because of the drawdown curve, this is the drawdown curve. पानी जब कम हुआ तो water table यहाँ पे थी, it is reduced to this line, red line here, okay, that is there, and the width of this here is dy, okay. This is the assumed flow pattern जो कि हम horizontal मान के चलते हैं इसमें. This is the assumed flow pattern. जिस distance पे हमने ये point assume किया है p x, y, that is the x distance, okay. This strip is at a x distance. This r is the radius of influence जो आप हमेशा जानते हैं. h क्या है? h एक static head है किसका? water table का. और h हमेशा हम अभी तक डिस्कस करते आए हैं इस पूरे मॉड्यूल में, that it is the height of the initial water level above the bottom of gallery, and the small h is what? It is the depth of the water in the gallery on pumping at equilibrium. So these are the two terms that you have to see. Now again, if you want to derive the formula for the discharge from this infiltration gallery, you can see here that q is equal to k into I into A. Considering a point P on the drawdown curve, that is this point here, that is the point P x, y, and a small element of width dx, that is this small element of width dx, the head gradient will be dy by dx. So that will be the head gradient जिसके कारण पानी का flow यहाँ पे possible है, and also the area of the soil through which flow will occur is equal to what? Y into L. So that is the area through which the flow will be occurring. Therefore q is equal to what? Integration में it is what? Q is equal to k I A, okay. So this is the area y into L, I is the hydraulic gradient, that is dy by dx, and this is k. So if you talk about this, and if you are putting it here, so you can simply integrate it, and when you integrate it, the value comes out to be what? Q is equal to k into L into h square minus small h square upon 2r. So that is the discharge value which you will be getting from the infiltration gallery. Now let us take a look at the numerical here, that is 600 meter cube per day of water has to be obtained from a proposed infiltration gallery which is placed at 6 meter depth from the subsurface water table. So that is there, that is given to you. Coefficient of permeability of the soil aquifer is 100 meters per day. Next point that is given to you is the radius of the influence may be assumed to be 100 meter. अच्छा, एक पॉइंट क्या है कि आपको निकालना क्या है? Find the length of the gallery if the drawdown in the gallery on the pumping is not to exceed 4 meter. Okay, that is the point there. Now what is the data given to you? 600 meter cube per day of the water has to be obtained. इतना पानी हमें रोज का चाहिए अपने काम के लिए. The permeability is what? 100 meter per day. Radius of influence कितना दे रखा है आपको? 100 meters दे रखा है. What is the depth here? That is 6 meter depth. Okay, that is the h is equal to 6 meter. अब एक चीज़ और बोली गई है, find the length of the gallery if the drawdown in the gallery on pumping is not to exceed 4 meter. So if I say that this h is equal to 6 meters, h is equal to 6 meter, and the drawdown is not to exceed 4 meter, so you can easily find out this small h. Okay, this is h minus s. Small h क्या है? This is the water table height. जो नई water table हुई है उसका height कितना है? That is small h. This is 6 minus 4, that is equal to 2 meters. अब आपको formula पहले से ही पता है for this infiltration gallery, that is q is equal to k into L into h square minus small h square upon 2r. So you know the value of this discharge here, that is 600, and it is equal to 100 into L into 6 square minus 2 square upon 2 into 100. So जो infiltration gallery है that is coming out to be what? 37.5 meter. तो यदि आप इसको top view में देखेंगे, so this length is what? 37.5 meters. इसका यदि आप cross section देखते हैं, okay, if I say that this is the wall, this is the foundation, and the water is being stored here. So this is what? this water will be coming on from this area here and it will be getting into this infiltration gallery, जहाँ पे जो h की वैल्यू दे रखी है, that is 6 मीटर, कितना नीचे यहाँ पे पानी है, that is there, and also the drawdown is not to exceed what 4 meters. तो ये जो आपके पास डेटा यहाँ पे मौजूद था जिसकी मदद से आपने 637.5 मीटर निकाल लिया. द डिस्चार्ज फ्रॉम दिस इन्फिल्ट्रेशन गैलरी जो आपने बनाई है, that was what 600 मीटर क्यूब per day. So using this data you have easily found out the value of L, and using this formula you have got the value. So with this we come to an end of this entire lecture series of irrigation and water resource engineering. इस पूरे lecture series में जो हमने समझा है, that is the हाइड्रोलॉजिक साइकिल के कंपोनेंट्स क्या क्या थे उसके बारे में हमने डिस्कशन किया था. देन वी टॉक्ड अबाउट द इवेपोरेशन प्रोसेस, इवेपोट्रांसपिरेशन प्रोसेस एंड ऑल्सो द कंजम्पटिव यूज, दैट इज द इवेपोट्रांसपिरेशन. ऑल्सो वी हैव डिस्कस्ड अबाउट द स्ट्रीम फ्लो मेजरमेंट टेक्निक्स जो कि हमने सेकेंड यूनिट में ही पढ़ा था, एंड ऑल्सो वी हैव टॉक्ड अबाउट इट इन द दिस यूनिट ऑफ द दिस वन, दैट इज फोर्थ यूनिट, जहाँ पे हमने डिस्चार्ज मेजरमेंट टेक्निक्स पढ़ी थी. बेसिकली स्ट्रीम फ्लो मेजरमेंट एंड द टेक्निक्स टू मेजर द डिस्चार्ज for the canal also they are more or less same, because वो एक तरीके से stream ही है. Okay, one is a larger one and is a smaller body. And the hydrograph theory we have completed in this for computation of runoff. So runoff, infiltration and different other components of the hydrologic cycle we have covered in detail in the first 2 units. In the third unit we went for the irrigation channels and the water logging preventive measures. तो इसके अलावा भी हमने कई सारी चीज़ों का डिस्कशन किया था. Along with the water logging we also discussed about the canal lining along with it, so that the water logging problem does not exist. इरिगेशन चैनल कितने प्रकार के होते हैं, किस तरीके से फंक्शन करते हैं, मेन चैनल क्या है, ब्रांच चैनल क्या है, उसके बारे में हमने यहाँ पे डिस्कशन किया था. आफ्टर दिस वी हैव डिस्कस्ड अबाउट द रेगुलेटरी एंड द कंट्रोल सिस्टम ऑफ द कैनाल, जहाँ पे हमने बात करी थी अबाउट द कैनाल रेगुलेटरी वर्क्स. ओके, व्हाट आर द डिफरेंट रेगुलेटरी वर्क्स दैट कैन गो फॉर one can go for, and these were to use for the control of the velocity of the water in the canal. For the discharge control we can use these regulatory and the control systems. And we also discussed about the irrigation outlet, कि semi module outlet क्या है, that is a flexible outlet, non modular outlet क्या है and modular outlet क्या है. We also discussed in detail about the Gibbs module. उसके बाद हम यहाँ पे बात करते हैं लास्ट यूनिट में हमने जो आज ख़त्म करी है, that is the application of the ground water hydrology and also the determination of the discharge through wells. तो इसमें हमने steady flow through aquifers हमने बात करी थी. We have also discussed about the different aspects of lifting of the water from the ground, how that water can be utilized for our own purposes and for the irrigation purpose. So these are the 5 units that we have covered here, and a few topics of the groundwater hydrology can also be seen in the engineering hydrology subject, wherein the topic of partially penetrating well, image well and several other topics have also been discussed along with the unsteady flow. So with this we come to an end of this subject, and hope you will be understanding this here. And also the reference materials for this entire lecture series preparation has been taken from these 4 references here, and other research papers have also been consulted with. Thank you for today.